I'm Mark Sponsler, and welcome to the Stormsurf Videos Surf Forecast for the week starting Sunday, March 28th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the North Pacific Ocean, we don't see a whole lot going on. A little bit of low pressure generating, maybe 14 or 15 foot seas in the northeastern Gulf. And a broader gale is pushing up over the dateline into the Bering Sea, but generating nothing of interest for Hawaii or California. So, the seasonal transition is underway. As usual, we'll start by looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a dip in the jet, just like right there, and that helps create a counterclockwise flow aloft and also down at the ocean surface, and that is the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, radiate away from the fetch area, eventually turning into swell. And swell, when it hits your beach, turns into surf. So troughs are an important aspect of the dynamic that we're investigating. All right, so we do have a little trough here off of Kamchatka and North Kuril Islands, but notice winds are very weak blowing into its southwest quadrant. That won't do a whole lot for generating gale development, but we do know there is some sort of a gale in this area, so it is doing something. Also, there is a very small trough, barely exposed to open waters here off of British Columbia. Not sure if a whole lot is happening there either. The main thing to notice, the jet pushes off Japan, splits heavily with the northern branch running up over the Aleutian Islands, and pretty much overland the whole way into the U.S. mainland. The southern branch way to the south, even south of Hawaii, dips up a little bit there over the islands and then into Baja. In between the two streams, pretty typical, massive high pressure, and that's exactly what is going on. Let's put this into motion, see if we can discern if there's any favorable outlook for the future. We're already out into Tuesday. All we're seeing is the massive split, a little bit of a trough here, trying to push into the Gulf on Wednesday, very far in the northern Gulf, when with almost no wind. What is that, 70-knot winds feeding it, so that isn't going to do a whole lot for anything there. But then as we get into Thursday, Friday, the jet ridges hard in the far west Pacific, but then starts making a dive to the south over the Gulf of Alaska as we get into Thursday and even into Friday, perhaps offering a modicum of hope. Maybe not even gale, but maybe just low pressure there. And that kind of pinches off as we get into Sunday and pretty much fades out, moving into North California a week from now. And again, the massive split in the jet still in control. So not a whole lot of hope in the northern hemisphere. At some point here, we will transition to the southern hemisphere, but seeing how it's March, we're still holding out some hope for the northern hemisphere waking up and maybe doing something. And there's some indications that perhaps maybe a week out we could get something. Next up, we look at surface level pressures, surface level winds. We are not holding our breath here anywhere. 1032 millibar high in the West Pacific, 1040 millibar high over the Gulf of Alaska, the northern Gulf, and a 1028 millibar high off of California. Doesn't leave a whole lot of room for low pressure development. There's our gale, currently moving into the Bering Sea, producing 40-knot winds, but all of it landlocked behind the Aleutian Islands. No hope there. And also there was a little bit of fetch here right off of British Columbia, 30-knot winds, but that, as we get into Monday, moves inland, and no hope there. Notice winds building off of Cape Mendocino as we get into Monday night and Tuesday. Good for local wind swell relative to California, but that's pretty much it. Continuing on, another strong 1040 millibar high builds over the North Dateline region as we get into Wednesday, and kind of holding there into Thursday and Friday, and just, we don't expect much with the jet. You can see the jet stream, it's like doing this and this, and that's where all the fetch is, and in between there's virtually nothing. Now, we knew there was a little bit of trough supposed to be forming over here in the Gulf as we got into Saturday, Sunday. Even that hasn't appeared to manifest in anything on the models yet. If anything, a 1040 millibar high filling the entire Gulf of Alaska, down to Hawaii, and even almost to Japan, so no hope there. Next up, what is the effect of those winds on the ocean surface? And as you can see, we are now running the GFS version 16 wave model. It is the old NOAA OMB wave model that's been assimilated into the GFS model. Much higher resolution. This is great for, and we'll get into this in a bit, watching Swell try to plow through islands and around stuff like that. You also see a lot more detail here. You know, before it was sort of like a cartoonish image. Now you see a lot more little random things popping up here and there. Notice this line here, which would normally have been just sort of a straight line, has a lot of like little wavers in it. So the model can sense out very small things a lot easier, and the net effect is its ability to calculate swell heights and sea heights is affected positively in that it more accurately reflects what's actually happening out in the ocean. All right, anyway, so we go into Monday. Not a whole lot going on. Here's the fetch. It's a local fetch. What is that? A 18-foot seas off a California building. Roughly, almost 19.7 feet. Okay, but that's all wind swell, not real swell. Another area sees 18 feet on Wednesday over by the date line, aimed at none of our forecast area, off to the east, if anything. And then we continue on Thursday, Friday. You get a general sense of something trying to push down here, but seas are, what is that, 8 to 10 feet, 9 feet, 10 feet right in there, so not a whole lot. Then notice, remember there's a big high pressure setting up. Look at the dead air in the middle of the high with seas. Oh, what is that? Probably about 2 or 3 feet, something like that. That's not very much. And getting even darker as we get into Monday. So North Pacific, in short, pretty calm. Let's go look down south. Now this is interesting. We're going back to last Sunday. A gale pushed under New Zealand. We're not only showing this because there's swell radiating north from this system, but also you can see the transition from the old model to the new model. When we get Monday 12Z, that's the first frame of the new model. Notice seas 28, 29 feet. And then we get Monday 6Z, this broad area of 30 to 32 foot seas. Now you move to the new model, it goes, not so much. That last model overhyped it. Here's the reality of the situation using our new enhanced high fidelity modeling capabilities. And you see seas drop down to 28 feet, maybe one little pocket of 32 feet. We'll just go back and forth, you see right there, and get it pretty clear. Anyway, that system moved under New Zealand. Swell is in the water pushing northeast. Another system followed behind that. Actually, yes, into the southeast Pacific this Friday. Seas were also notice this, 33.8 feet, but notice this, 56.2 south. Okay, so the grid is actually, it's a 1/4 degree grid, and actually underneath that, it's down to a 1/6 of a degree grid. So we got to go update some of this stuff. It should be 56.25. So you see these 0.2s and 0.8s, which really should be 0.75s in the center of the grid squares. So we'll get around to fixing that at some point here, but we're still trying to fry some bigger fish, trying to clean up some of the mess from the transition. Anyway, another gale built in the southeast Pacific as we got into Saturday. Seas, let's see, it peaked out right there around 34, 33. Did we get it? Yeah, we got 35 feet. So there's swell coming north from that too into mainly Southern California and North California about a week out. So something to look forward to. But then after that, there we are. We are done. Now we're going to do one other stop here. Actually, before there, we need to go out. That was the hindcast. Let's look forward. The South Pacific, pretty much after that, gets quiet. Little system tries to push under New Zealand. Not a whole lot expected from that. Another system falling southeast. And that's it for the next week. So there's a run of swells. I think there's a total of 3 of them bound in for California and 1 for Hawaii, maybe 2. Nothing huge in size, but something. And then after that, things go quiet, and wind swell will probably become the main focus. So here's what we wanted to show you. The high-res model, this is projected surf heights. But what we're really trying to get to, notice this swell here in Tahiti's somewhere around in here and the associated islands. Watch this as the swell front hits the islands right there. You can see it starting to get shredded, and this side of the swell pushes north, and it's just like a blockade right there. You can see that? We'll run this out a little bit further, and then we'll do the whole, and there's another swell, the same thing happening, and we'll do this, we'll run the whole loop again so you can see it. Okay, here we go. So there's one there. The cheese grater effect happening. Anything west of this point, notice there's no swell. Everything is east, pushing towards, of course, South America, Central America, and California. So it's real key that storms be either here in the southeast Pacific or over here in the far southwest Pacific to get around this blockage here, this swell shadow, if you want to call it that, because it is a pretty totaled up blockade, and well illustrated here in the new version of the GFS WaveWatch model. All right, next up, local wind swell. Looking for California, Hawaii. Trades blowing 15-20 knots. Wind swell along east-facing shores of Hawaii. No swell for California at the moment, but as we get into Monday, high pressure 1044 millibar bulletproof high. Winds building to 35 knots. The difference in pressure between high pressure here and lower pressure inland, heat-induced low pressure, creating the isobars, letting the isobars tighten up, creating strong winds, 35-knot winds. Maybe even a pocket of 40-knot winds late Monday evening. So good amount of wind swell expected for California as we get into Tuesday. Trades backing off for Hawaii. On Wednesday, then everything calms for California. Trades even pretty light for Hawaii. The new big high-pressure system sitting well off to the west. Low pressure in the Gulf of Alaska, light wind flow. We're into Thursday, Friday. No real wind swell expected, but there should be small southern hemiswell, so that should do something. But then as we get, I think later in the weekend, nope, not even yet. Where are we? We're almost there. And then there's some hope for wind swell developing again as we get into Monday, and certainly trades. Let's go back here for Hawaii. There we go. As we get into Saturday, trade winds pick up for the Hawaiian Islands, and wind swell expected there as well. Precipitation for California, well, with high pressure as strong as it is, no reasonable expectation of precip, not even a dribble into Cape Mendocino as we get into Monday, Tuesday, Wednesday, just high pressure locking things down. But the models are hinting, if you want to believe this, as we get into Sunday next week, of some sort of precip moving in, and even snow in the mountains 180 hours out. And the 10-day GFS model suggests even a little bit more. Let's go take a look at that. Here we go. Squaw Valley, supposedly 10 inches all out there on around the Sunday, Monday time frame a week from now. And again, we don't believe a model 4 days out, much less a week out, much less 10 days out, but something to keep your eyeball on. Snow levels quite high, 10,000 feet. Going up to 12,000 feet the end of the month, still hanging around the 10,500, 11,000 foot region. But then as we get into about a week out, notice they drop down to as low as supposedly 3,500 feet or less, 3,000 feet. Don't know if we really believe that or not, but something to keep our eyes peeled on. Let's go take a look at Kirkwood. Kirkwood about in the same spot, 10 inches of snow. Snow levels, this is the blue line's the top of Kirkwood, black line is the base, so snow level way above even the top the whole way through the end of the week, but then falling down to, well, it's where the white is here, so it's at 2,000 feet, 2,000 to 3,000 feet, if you believe the models. Let's go take a look at Mammoth. And Mammoth, being further south, gets about 4 inches, something like that. Snow levels, well, at least up at the top, it stays pretty much cold. Now, that's not good for corn snow production. You really want above freezing temperatures for a week, something like that, including in the evenings, continuous above freezing temperatures to get good corn snow, and then again, dropping cold again a week out. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation and, of course, the El Nino Southern oscillation. And we have some interesting news. There is quite a bit going on down south. As usual, we'll start by looking at winds across the equator in the Pacific. This is the East Pacific here. This is the West Pacific here. The arrows are the wind speed and direction. The longer the arrows, the stronger the winds. This data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. The equator is right there. So that's the East Pacific. Dateline, 180 west, right there. New Guinea, right there. And specifically, we're interested in the far West Pacific. We call it the Kelvin wave generation area. When the MJO, the Madden-Julian oscillation, oh yeah, and let's go into this. If the MJO has two phases, and it's a periodic weather oscillation that travels west to east around the equator, around the whole planet. One phase is the active phase, the other phase is the inactive phase. Wherever the active phase is on the other side of the planet is the inactive phase. All right, what we're looking for is the active phase, and especially when it moves over the West Pacific, because what that does, it imparts energy to the jet stream, both north and south, the southern hemi and northern hemi, but also stomps on the trade winds and allow warm water that's typically pooled up here to start pushing east, but not on the surface, under the equator. That warm water pushes the whole way across the Pacific, takes about 3 months, and eventually will erupt off of Ecuador near the Galapagos and create in that ball of warm water is called a Kelvin wave. Eventually, when it erupts at the surface over in the East Pacific, it'll push warm water to the surface. It gurgles up on the surface, erupts to the surface. Warm water starts filling what is normally very cold, nutrient-rich waters in the eastern equatorial region, and that can change weather dramatically, because when you raise the temperature of water, it increases the amount of evaporation, and the more evaporation you get clouds, you get condensation. All right, so El Nino is characterized by warm water building up in the East Pacific. La Nina is characterized by cool water building up mainly over the equatorial Pacific, but we like to really focus on the East Pacific here. All right, so anyway, but it's not the actual wind speeds that matter. It's the differences from normal for this time of year, and that's what this anomalies chart means. So in the East Pacific, we see the arrow is a little bit out of the east, a little bit stronger than normal, so trade's a little bit stronger. But in the Central Pacific, they're dead neutral. Then over the Kelvin wave generation area, they are enhanced a bit. So the active phase of the MJO suppresses trades. The inactive phase enhances them. This looks like the enhanced phase since we have stronger than normal trades. What's the forecast for the next week? And why are we going into all this? Well, one, we're looking for the active phase of the MJO. And two, we're looking for it to move over the West Pacific. And three, we're looking for it to create a Kelvin wave, because if you get multiple successive active phases of the MJO, they can help kick off El Nino by producing warm water that starts moving across the Pacific off the Galapagos. That's why we're so focused on the MJO. And of course, the second benefit of the active phase of the MJO is it helps feed energy to the jet stream, and that in turn helps produce swells and storms. All right, so the inactive phase does the exact opposite. It pretty much stomps on everything. All right, so we're looking in the Kelvin wave generation area. 135 east is the far West Pacific right here. This is the whole planet on one chart, by the way. Date line's right there. The East Pacific is right there, like Ecuador is right about there. All right, the blues are easterly anomalies. Consider that the inactive phase of the MJO, and you can just look down for the whole month. It's pretty much been inactive phase of the MJO. Now we see starting today, these reds, these are westerly anomalies building. Well, the West Pacific starts right here. So this is over the maritime continent, Indian Ocean, not pushing into the Pacific. And we see strong easterly anomalies that have been in control of the Kelvin wave generation area, but you see them starting to slide off to the east, suggesting that perhaps the inactive phase of the MJO, which has been in control, is starting to move east, and maybe the active phase, a week from now, maybe might be getting some foothold in the West Pacific. All right, looking out 2 weeks. So this is outgoing long wave radiation, another component of the MJO. The MJO acts like a low pressure system. The active phase does. The inactive phase acts like a high pressure system. Low pressure generates clouds. Clouds allow less sunlight to reflect off the ocean surface. So the orange, here we go. South America, Central America, Mexico, Hawaii, the equator running right along there. Dateline right there. There's Australia, New Guinea. So the Kelvin wave generation area right about here, 5 degrees north and south of the equator. We have this yellow, that is positive anomalies, more sunlight reflecting off the ocean surface, indicative of the inactive phase of the MJO. Maritime continent here, Bali's like right there. That is the active phase of the MJO. Less sunlight reflectivity, more clouds. So 5 days from now, hey, the inactive phase is moving east as the active phase tries to get a foothold in the West Pacific. And then a week from now, active phase strongly in control of the West Pacific and continuing 2 weeks out. This is exactly what we want to see. Now that's the statistic model. The dynamic model, this image is all corrupt. And eventually someone will get around to fixing that. These are not our charts. They're produced by NOAA. So we'll have to be patient and wait on them. But we can look at the phase diagrams, and both these appear to be in good shape. This is the statistic model. This is the dynamic model here. All right, what are we looking at? Well, the MJO moves from west to east, from the Indian Ocean, over the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. The heavy dot is where the active phase is. Okay, the further it is away from this circle, the stronger it is. So we'll say a weak active phase centered over the West Maritime Continent today. 3 different projections suggest, well, 2 of them suggest it moving to the West Pacific and still very weak. But the third projection suggests a very strong active phase over the West Pacific 2 weeks from now. That per the statistic model. The dynamic model suggests probably more somewhere in between these two, with a modest active phase pushing to the West Pacific and then collapsing there 2 weeks from now. So something to keep our eyes on. Now you got to keep in mind, for months now, the long range models have been suggesting a strong active phase traversing the West Pacific somewhere in the next couple of weeks, and that should have a significant impact on the current La Nina base state. So we're going to get into more on that in just a little bit. All right, let's go out a month. And this is from the CFS model. Again, east anomalies, west anomalies. What are we looking at here? Okay, so here's the day, March 27th. Okay, the date line, right up the middle of the chart. West Pacific starts right about here. East Pacific way over here somewhere. But the Kelvin wave generation area ends at 170 west, so right there. So what are we looking at? Well, the blues, you can clearly see we have strong east anomalies in control today. The dotted contour here, we'll just show it there. MJO is the black line. The dotted contour is the inactive MJO. So it's strong in the core of the Kelvin wave generation area today. But remember, it travels from west to east over time. So you can see it's to fade out about, each one of these is a week, so maybe about a week and a half out from now. And then the active phase, they show it as multiple circles here, but it's pretty much one long wave pushing from west to east like a bulldozer. And you can see west anomalies from it trying to get a foothold in the West Pacific 2 weeks from now, and then almost filling the Kelvin wave generation area for 2 weeks after that. This is the big active phase that we've been looking for. Again, still 2 to 3 weeks out from being real, but this is what we're putting some hopes on to help eliminate La Nina. And then finally we go to the CFS model. This goes out 3 months, and it again, whole plan on one chart, date line right up the middle, but past performance is down here. Okay, Kelvin wave generation area from right up through there to about there. You can see since November, nothing but the blues, east anomalies, a little bit of a break there in February, east anomalies building in, but then forecast to fade. And then here's this pretty good, healthy batch of westerly anomalies forecast somewhere starting mid-April, going the whole way through mid-May, and then still hanging around after that. The exact opposite westerly anomalies in control over the Kelvin wave generation area as compared to that. If this were La Nina, we're not saying this is going to be El Nino, but at least maybe it's enough to nudge La Nina out and get us into a neutral pattern. All right, let's overlay the MJO here. All right, so here's where we are today, the dotted contour, the inactive phase of the MJO, feeding easterly anomalies. But as we get into, even April 5th, the active phase starts moving into the West Pacific, completely filling it from April 13th up to about May 7th, or maybe even beyond that, May 15th, something like that. West anomalies in control. Possible development of a Kelvin wave, another Kelvin wave, because there's one already in flight today. We'll get into that in a second. And then another inactive phase after that. But notice, westerly anomalies still pretty much taking control. It appears that there is some sort of a pattern change setting up, and we can talk about that now. Here we go. The high pressure bias, low pressure bias, the low pass filter. The dotted contour is high pressure. Okay, and there's the date line, and you can see 1, 2, 3, 4 contour lines, has been in control since December. But the good news is, notice this fourth contour line fades out in mid-April, third contour line the end of April, the second contour line mid-May, and then the remaining contour line pushing out of the Kelvin wave generation area altogether by about the end of May. And what's this solid line here? This is a low pressure bias that has been locked over the Indian Ocean for months now. Notice it starting to ease its way in to the Kelvin wave generation area. And by, at that point in time right there, filling the Kelvin wave generation area by the end of June with low pressure. And that's probably, pretty much we can say that is why the westerly anomalies are forecast to start taking root in the Pacific. This is a major plus for the Pacific and maybe even for the end of our summer. Now notice, when this happens, it is not an immediate switch. The atmosphere just doesn't go, boom, I'm going to change and I forget that La Nina ever exists. No, it'll take 3 to 5 months after this happens before the global circulation starts changing, which means this has to stay like this for 3 to 5 months after this point in time, and the model clearly doesn't go out that far, to give us a sense of, what's our late summer, early fall, next winter sort of time frame going to look like. And you might go, well, this is crazy. Why we don't barely accurately be able to predict surf more than a week out? Why are we talking about going out 3 or 4 or 5 or 6 months? Because when you look at these things, you can get a general sense of where we're going. And believe it, though the specifics are not there, the general trends are actually often pretty accurate. All right, so another key component of El Nino, La Nina, is water temperature balance. Where is the warm water at? Where's the cold water at? So we use the TAO buoy array again, that series of buoys strung across the equator. This is the East Pacific, West Pacific here, date line right here. These little X's, these are the anchor lines on the buoys in very, very deep water, the whole way across the equatorial Pacific. Holding the buoys in place, and little X's are the sensors on those anchor lines. They record temperature data at different depths of the oceans and then relay that up to a central processing facility. They apply a model to it, get a profile of the heat balance. Warm water, you can see clearly broader in coverage in the west, much smaller in coverage in the east. But all it takes is little changes in the balance of this water, of the warm water, to make a giant difference in the atmospheric circulation above it. Right, so 28-degree isotherm, it's been pretty much there. I think it went to 175 west at one point a week or so ago. It's backtracked a degree or two, but appears to be stable at the moment. 24-degree isotherm, if anything, is getting thicker in this region. The depth of 24-degree or better centigrade water building in coverage, meaning that warm water appears to be pushing off to the east slightly. But it's not the actual temperatures, it's the anomalies, differences from normal for this time of year. And even 2 or 3 weeks ago, we had like 4-degree anomalies all balled up in a wall here. The cutoff line was 165 west, which is right here. In 2 or 3 weeks, there's been this big explosion of warm water pushing off to the east. The line, according to this model, is now at 125 west, suggests there's a Kelvin wave in flight. That is warm water pushing to the east at depth. Notice here's the surface. It's moving under the ocean surface. Also, there was a lot of cool water right here. This is acting like a bulldozer, and what it's doing is pushing this cold water to the east, and when it hits land, it starts gurgling to the surface. And we're going to see that again in just a second. Another model here, higher resolution, suggests the warm water traveling even further east to about, what is that, 110, maybe even 108 west, which is beyond California, somewhere south of central Mexico. And temperatures 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 3 to 4 degrees above normal in pockets. So it's interesting. When the water's all balled up here, it gets real warm. It starts losing temperature as it spreads out. But then as it starts pushing up to the surface here, it will start warming again. Also, you can almost also see all this cold water here? This is the leftovers from La Nina. As this pushes east, that cold water has to go somewhere, and where it's going is up to the surface. It's getting squeezed from below up to the surface and erupting on the surface, a precursor or a signal that a Kelvin wave is in flight. One more piece of evidence, sea surface height anomalies, right? This is from the JSON 3 satellite data, JSON 3 satellite. And that measures, you can use it to measure sea heights in storms, but also if you strip out the waves, strip out the wind waves, and you use it to just see the sphere of the ocean or the height of the ocean relative to a normal sphere, you see, well, what we have been seeing is minus 10, minus 15 centimeter anomalies. Oh, there's Chile, Peru, Central America, Mexico, Baja, Hawaii right there. That's the equator right there. Dateline right there. New Guinea there. And what we see is neutral to slightly positive anomalies pushing under the equator, over the dateline, south of Hawaii, to a point almost south of California right there, and likely beyond that. And what this suggests is warm water, of course, because it's warm, it expands, and when it expands, it displaces the water above it and causes a little bulge on the ocean surface. And that's what this chart is measuring. Just another way, it's not direct measurement like the TAO buoy ray, but an inferred sense of where warm water is and where it is not. And generally what we're seeing is a dramatic improvement in subsurface conditions along the equator. And that's all we care about. 5 degrees north and south of the equator, from Ecuador the whole way over to New Guinea. And this chart puts it in time perspective. Goes back a year, but we're just really interested. Okay, let's say June of 2020. Last Kelvin wave, warm water. This is the West Pacific. This is the East Pacific here. Blue is cold temperature. Yellows, oranges, and reds, warmer temperatures. Last little Kelvin wave tried to dribble across the Pacific on the equator, didn't make it. Then we had our major upwelling event, cold water, peak of La Nina in the Halloween time frame, continuing until about mid-February. Notice the very warm water here, almost 2.5 degrees in little pocket. That's degrees centigrade. Started migrating off to the east. Today, the leading edge of it, according to this, 115 west, so just like what we saw in the other chart. And clearly, looks like a pretty strong Kelvin wave, certainly compared to this, or you can actually see the remnants of one there even in April of last year. So a dramatic change, at least for the moment, appears to be taking place. Now let's take a look at sea surface temperature anomalies, differences from normal for this time of year. And you go, well, wait a minute. I see what looks to be cold water upwelling off of Peru and Ecuador. There's the Galapagos, little warm water there. I see cold water along the equator. How is this possibly a sign of the end of La Nina? But I do see warm water here building up along Mexico and off of Peru. But what we think is going on is that last bit of cool subsurface water that's under the equator, not at the surface, is being squeezed to the surface by the Kelvin wave, which is theoretically, where is it? Somewhere right along about here. So ahead of the Kelvin wave, it's squeezing warm water to the surface, and the only place that warm water has to go is up. So we'll get a cold shot here for a little bit, and then theoretically, maybe a month or two beyond that, warm water will start showing up in it also gurgling to the surface, filling in this area with at least neutral temperatures, if not warmer than normal temperatures. And we know there's another Kelvin wave in flight behind that, or another active phase of the MJO, which could produce another Kelvin wave. So that would give us theoretically 2 Kelvin waves in pretty close proximity to one another. Maybe it's the sign of a change. All right, and then of course here is the 7-day sea surface temperature trend. You can see dramatic cooling of waters along Peru, Ecuador, the Galapagos out here. Again, we think that's a sign of the impending Kelvin wave. At one point we're thinking, well, there is the inactive phase of the MJO that is moving from here over to here, and it is feeding trades, which would probably be cooling waters. And that's also true. It could be an interaction of both these things happening at the same time. Though the speed at which the Kelvin wave is moving and the amount of warm water in it seems to suggest that this cooling trend was, I'll give it more like 65 to 70% attributable to the incoming Kelvin wave, and 30% to the inactive phase of the MJO moving towards this region. Sea surface temperature anomaly is just the backed off view. There's our cold upwelling water. Now this is this bit here, and this bit out here. That's true remnants of La Nina. High pressure here circulating like this, driving upwelling off of California. If you were in the water this weekend, certainly in Northern California, you know it is anything but warm. I mean, temperatures were, I'll be generous and say 51 degrees in San Francisco, if not colder than that. And the same thing's going on here. High pressure circulates counterclockwise, causing upwelling along here. They both feed together. And again, La Nina is an enhancement of the high pressure systems of both the north and southern hemi, which cause this upwelling. El Nino, the exact opposite. It stomps on the high pressure. It reduces upwelling and temperatures start warming here. When you get a warm pull here, you get more cloud cover, more evaporation, and then that feeds the jet stream. The jet stream falls south in the fall and winter months. You get more precip into California, more snow, and the storm track moves a lot further south. A lot more energy is fed into the jet stream, and then you get more longer lasting storms, stronger intensity, and more of them. Sea surface temperature trends in the Nino 1.2 region is the area right up there along the Galapagos and Ecuador. No big surprise, they're plunging down to a half degree, 575 thousandths of a degree below normal. Not surprising given the upwelling that's going on there. But in the official El Nino region, the Nino 3.4 region, this is the area on the equator south of California out to about the dateline. Temperature's doing pretty good. Quarter of a degree. 241 thousandths of a degree below normal. Not even in the La Nina territory anymore. It's got to be half a degree below normal for 5 consecutive 3-month periods. So this is not, we've only been here, 1, 2, 3 weeks. So this is not to say we're out of La Nina, but for the moment, we're trending away from it. So what does the atmosphere think is going on? The atmosphere above the Pacific Ocean, north and south, is coupled with the ocean itself. When the ocean warms, there's more evaporation, and then the atmosphere changes in response. So we use the Southern Oscillation Index, difference of pressure between Tahiti and Darwin, Australia, to sense whether there's lower or higher pressure than normal over the Pacific. When there's lower pressure, that is at least a sign of the active phase of the MJO traversing the Pacific, but if it persists over a long enough period of time, maybe that's the development of El Nino. Today, The daily contribution. Oh, and when Tahiti, so when the pressure is lower in Tahiti, which is over the Pacific, the index goes negative. Well, we're not negative. It's 3.54 today, but that's not exactly horribly positive either. You can go back and see we've been sort of jumping back and forth lately on the daily numbers, suggesting kind of a neutral trend. 30-day average, look at this. Hey, we are negative, 0.44. Down to 1.69 the other day, but you can see a month ago we were at 10, 11. So we're moving into neutral territory. The 90-day average, so this is your, we'll call this the active-inactive MJO phase indicator, suggesting, well, maybe we're moving towards an an active phase of the MJO. The 90-day average, 9.74, still quite positive, clearly a La Nina signal, but we were up at beyond 15.5 a month or more ago. So it's trending in the right direction. Let's go take a look at a graph here. Here we go, 30-day moving SOI average right here. This tells you everything you need to see. A massive drop in the Southern Oscillation Index in between January and April, suggesting the atmosphere is moving towards lower pressure in the Pacific, suggesting the demise of La Nina. Now, you can see back even in, where did it start? Somewhere around October 2019, there was this slow rise in the SOI, and it just kept, the active phases were here, right, the downward pushes, but the inactive phases got the upper hand and kept driving it more and more up into the positive to a plus 20 range. Today we have a reset now. We're at neutral or so. The question is, where are we going to go from here? But with one Kelvin wave in flight, the active phase of the MJO building in, suspect we are going to continue to drop to some amount. And finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region from the CFS version 2 model. This model has had a constant cold bias, and it is still doing that, but slowly rising up. So where were we? So here is October of last year when we were cold, down about minus 1.25 degrees, the peak of La Nina. We've been on a steady warming temperature trend since then. Today in the, let's say minus 0.15, maybe minus 0.2 degrees, and forecast to hold there into June, then theoretically dropping down to a half degree below normal as we get into the fall, which would be bare minimum La Nina territory. But again, all the other models not shown here are saying no, we're going to go to a neutral, dead neutral phase. So the point being, the MJO activity we're seeing, the Kelvin waves that are in flight, all that sort of thing, is not going to push us to El Nino. It'll just get us back to normal. And given where we're at right now, normal would be a great gift compared to being down in the depths of the cold and the wind and everything else, and massive high pressure locking down the Pacific as of right now. So, right now, the outlook generally favorable, though this model here tends to be biased on the cold side. The other thing is we're in the spring unpredictability barrier from March into about the end of May, and the models have a hard time deciding what's going on. So we got another month and a half before we really have a sense of where we're going to be at. By then, that first Kelvin wave should nearly be impacting Ecuador, and perhaps a second Kelvin wave would be on the way. So the good news right now is there's some small southern hemiswell on the way, but after that fades, maybe, just maybe, we're going to be stuck with nothing but windswell for a while. Not unexpected, that happens this time of year, but more than likely the southern hemi will wake up, and then we will be more in a situation to get some decent surf, though not as big as what we typically get in the winter. All right, long term looking out, well, things are drying up. Snow, some snow is forecast a week from now, but nothing meaningful, and we don't expect anything to happen, really. We're in La Nina. Total precip totals, we're at about 37% of normal for the season if the season were to end right now, give or take a percentage or two, and we suspect that's where we're going to end up. So a second very dry winter for California. We're hoping next winter will be much productive than the past too. But that's the way it goes. You take what you can get, conserve your water, do the best with what you have. All right, beyond that, the good news is, of course, a Kelvin wave appears to be in flight. A second Kelvin wave is possible, driven by the pending active phase of the MJO, so a couple weeks out, month out, something like that. And then beyond that, quite unknown, but if the low pressure bias shifts into the Kelvin wave generation area as forecast, and that has been forecast for months, then we should be in a much better place by next fall and next winter than we have been, certainly for this winter. All right, if you enjoyed the video, give us a thumbs up. Comments, always welcome. We try to respond fairly quick. Questions, you don't understand something, just post it there on the YouTube channel. We'll reply, do our best, or if nothing else, we'll address it in a future video. All right, if you haven't subscribed, please subscribe. If not, of course, the algorithms like it, right? And we got to make a little bit of money. Not much, but we make a little bit. And let's see. And if you don't want to subscribe, that's okay too. The link to the video is posted at the top of every page of our website, stormsurf.com, where all the models, most everything you've seen tonight is present there. You can enjoy it, peruse, test your knowledge, build up your forecasting skills, and then test it against our video at the end of the week on Sundays. And yes, we will do another video next Sunday right here. Same channel, same place, same time. So we'll see you then. Thanks for watching and have a safe week.